Okay, this is part 2 of the law of sines, and we're going to be talking about this ambiguous case of an angle side-side situation. Here's an example of that. We have an angle and we have two sides. The angle is adjacent to only one of the sides but not the other. It's different than, say, a side angle side situation where you'd have a side over here and you'd have an angle in between, or an angle side angle where you'd have that angle up there. So we don't know what these two angles are. So what we're going to do is we're just going to use our law of sines, and we'll say the sine of 20 degrees equals the sine of 20 degrees over its opposite side, which we're given as 7.9, equals the sine of angle A. We're going to try to find this one over its opposite side. If we cross multiply and divide by 7.9, we're coming out with a 8.66. Let me move this over so you can see it a little better. 8.66. In order to solve this equation, we have to use an inverse sign on both sides. So we do the opposite to both sides, and we got angle A equals the inverse sine of 0.866, which gives us 60 degrees. So we're real happy because we found this angle is 60 degrees. And if this angle is 60 degrees, that's 80, subtract from 180, this one's got to be 100 degrees up there. And everything is looking good. And I could use the law of sines again to find this side. Let's call this green side side Y. So if I want to find side Y, I would just go say sine of 60 over 20 equals sine of 100 over Y. I'd cross multiply and divide and find out what Y is. But what if the information was given to us and we weren't given a picture and we didn't know that it looked like this? That side, 7.9, could have been over here, which gives us a totally different looking triangle, which looks like this instead. Now angle A is no longer a 60 degrees, an acute angle. It's going to be an obtuse angle, it looks like, because this would be angle A over here now at that vertex. So what we want to do is, if we use the law of sines again, we're going to still come out with a 60-degree angle, but it's not 60 degrees. So think about this. If these were 60 degrees, if these two sides are the same and that's 60 degrees, then this one would have to be 60 degrees as well, because if any two sides are equal, the angles across from them are equal. It's one of the things we learned in 10th grade geometry. And if this is 60 and these two angles make a straight line, that would mean that angle would have to be 120 degrees. So our answer could be 60 degrees like we got here, or it could be 120 degrees. Our answer could be the acute angle, which the calculator will always give the smaller one because it just doesn't know what to do, so it always gives you the smaller angle. But we have to be smart enough to know that it could be a 60-degree angle here, or it could be a 120-degree angle over there. So you could have two different situations when your information is given in this form, an angle and two sides where the angle is not in between the two sides. That case, you would get two different answers. So that's the part of the information of this chapter that I didn't finish in the other one. What I want to do with you is do one last example where you have an angle that's missing. And let's do something like this. Let's say I'm given this angle. Let's just say that this is a 70-degree angle. And I'm given that this side is 10. And I'm given that, let's say I want to find this angle over here. We'll call it angle A. And we're given this side over here is a, I don't know, what's that look like? A little bit more than 10. Let's say it's 12. And I want to find angle A. I would go sine of 70 over its opposite side equals the sine of A, which we're looking for, over its opposite side. If I multiply the 10 up on the other side, I would put this in my calculator. And I would get an answer for what the sine of A is, but I wouldn't get the angle A yet. So I would go 10 times, you could do this on your calculator too, sine of 70 divided by 12, and this comes out to be a 0.783. So the sine of angle A would be 7.783. 0.783. To get angle A, we'd have to take the inverse sine, or in calculus sometimes they call it the arc sine, of both sides. So I would just go in my calculator, I would go second sine, that gives me the inverse, and I would go second answer, which is down below your negative button, and then hit enter, and I'd find out that this angle was 51 degrees. 51.5 degrees would be that angle there. 51.5 degrees. The problem is the side, sometimes it might not work. Sometimes this, since it's an angle side, this could also be redrawn, this triangle, so that this one was the obtuse angle. It turns out that this one, all three angles in this one are smaller than 90, so it's kind of, this is 120, so this is going to be like 59 degrees, 58.5 actually. So that if it's acute, it's okay, it works out all right. If it's obtuse, if you have a possible obtuse triangle, then you'd have to go with the two different answers. But I want you to see this part and how we use the inverse to get the missing angle. So that was the missing part to what we did before. So try those problems that are on page 720, 1 to 37, and then we'll go over them if you have questions. But you're finding missing sides and missing angles in these triangles using the law of sines. So I'll talk to you soon. If you have questions, let me know, and we'll do our video chat again on Wednesday. Your class will be what? 2 o'clock, right? So I'll see you Wednesday at 2 o'clock.